Yeah. Yes, good morning, my dear students. Is it audible for you now? Hello. Yeah. Now this year, now welcome to the B.Sc 3 now, that is 5th sem. Students, this year I'm taking the 2 units I'm handling now. One is paper 503 and another one is paper 501. Students, for this year, the syllabus is very, very interesting. It is almost very close to your real life. That is the application of the subject in your real life is more as compared to what the B.Sc 1 and B.Sc 2 that is. Because whenever it is more theoretical one now, that is always what happens now, you can understand the things much and much better way that is, rather than the mathematical language. But unfortunately, the students always they used to like the mathematical language, they will like derivations and all that. But in this B.Sc 3, most of the things are in theory part and very few derivations are there in this. That's why the many of the students they will not like it. But anyway, this year I'm going to teach X-rays. X-rays productions are there, Miller indices there, the crystal structure it is there. This is one. It is altogether it is 6 hours syllabus in that. Next one is thermal conductivity, electrical conductivity, wide-band fringe law, and statistical distribution, and all that it is there. And another point is the superconductors. That is very, very interesting one. Superconductors was very the burning topic when I was studying in the MSc and all that. That is important topic at the time, the superconductivity is. And next is semiconductor diodes, transistor is there. And also you studied in the PU second year, the PN junction formation, extrinsic semiconductor, intrinsic semiconductor, okay, the depletion region. All these things are very, very interesting as that. Apart from that, that one more that is what? Now the burning topic at present from the last 10 years is what? The nano materials, nanotechnology. The nanomaterials is very, very important nowadays. That is people are based on that. Now they are finding the vaccines or medicines for the what? COVID-19 and all that. Okay, let it be that. Now I'm going to start the X-rays. Dear students, if you are getting any difficulty, if at all if the sound is not audible, please make a call to me. That is, please make a call to my number. That is okay. For unmute, 1 minute. Yes, will you able to hear my voice? Yes,
Sir.
tell me now.
Yes, sir.
Is it audible? Okay. Again, I will unmute it. Okay, or else you can mute it. Unmute. Okay. Okay. Now I will start. Students, X-rays. Why it is called as X is because at the time these rays are unknown rays. Normally in our daily life we are using unknown person X we are calling it now like that. That's why he used the word X-rays. He used the word X-rays he used because at the time they don't know the properties of the rays. They are completely unknown. That's why he used the word the wrong X. And for the first time these rays was invented by the scientist Roentgen, that is Roentgen, 1895. Dear students, you know that every year the people are getting the Nobel Prize. One is in physics, one is in chemistry, one is in, that is what? The medicine, peace, and all that. No? Here, there is a question in your mind. Who was the first recipient of Nobel Prize in the physics? The first recipient of the Nobel Prize in the physics is Mr. Rontgen. Mr. Rontgen. He was the first man who discovered, who received the Nobel Prize in physics. Remember that. He received this Nobel Prize in the physics in the year 1901. That is, he received the Nobel Prize in the year 1901. He received. Okay, now here you see, that is highlighter is there. This person in the year 1901, for the first time he received the Nobel Prize in physics and all that. Next, as you know, that is electromagnetic spectrum. You know that. What are the electromagnetic spectrum? One is radio waves is there. This all comes in what? Radio waves. Next is microwaves. Next is IR. Yes, tell me now what is IR? Infrared radiation. Next, this part is that now this is called as a visible region. That is what we are looking all the colors. This is the what visible spectrum is. Next is UV rays, X-rays, and next is what? Gamma rays. What are the electromagnetic spectrum? Here. One is what? Radio waves. Here all FM, AM, all works in the what? In the radio wave region. FM1, FM2, AM, you know that. Next is what? Microwave. Next is infrared. Next is visible. Next is UV radiation. Next is X-ray. Next is what? Gamma rays and all that. But now we are interested in this part. We are interested in the what? The part is what? X-rays. We are interested in the X-rays part. Now, what are the properties of this? Here, X-rays have wavelengths ranging from 0.01 to 10 nanometer. That is roughly this. And you students, you see here, as a move from right to left, right to what? Left. That is when right to left. What happens is where the wavelength is go on decreases here. That is wavelength is go on decreases here. That is here, sir. Okay, 1 minute. Okay, as I move from right to left, then what happens is that is wavelength is decreases. As I move from right to left, the frequencies increases here. Frequency is what? Increases. And this frequency range is what? 3 into 10 to the power of 16 hertz to what? 3 into 10 to the power of what? 19 hertz. Don't remember these things much, but one should have an idea that is that's all it is. But gamma rays are having higher energy than the what? X-rays. Next, they travel through empty space through a velocity of how much? 3 into 10 to the power of 8 meter per second. They travel, the space is what? 3 into 10 to the power of 8 meter per second. Because they are all electromagnetic waves here. They have wave-like characters. Wave-like means sound also waves. Sound waves are, you know, that means it undergo reflection, it undergo refraction, it undergo what? Diffraction, polarization, and all these properties are what? It is what? Exhibited by the X-rays and all that. Whatever the properties of the waves are there, all properties are exhibited by the what? X-rays also. Because X-rays are the electromagnetic radiations. Next. Then what about energy that is? The energy of these waves is varies from 100 electron volt to what? 100 kilo electron volt. Kilo means 10 to the power of what? 3 and all that. Normally, for all practical purposes, the energy we are expressing in electron volt only. But it is not a SI unit. The SI unit is what? Joules. Joule is the what? The SI unit of what? The energy is that. Okay, fine. I hope that you are understanding all these things. Because in the first class, suppose if you are getting any difficulty about the audibility or the speed, any inconvenience is there, please, that is what, make a call to me. That is, I will attend your problem or I will resolve your problem. It should not be a waste of time. Next. They release heat when in interact with matter. That is what. That means, you know that. Please stand in the sun rays. Sun rays are nothing but what? Infrared radiations here. When you stand the summer season outside, what happens? The skin will become more heat. Skin gets heated. Even all vessels will get heated. In the same fashion, here they release heat when it interact with what? Matter. Because where energy is converted into what? Heat energy. And also they produce the chemical change. And biological too, that is. Biological also, that is. That's why, remember my students, normally when any part of the bone is fractured or any part, either leg or hand or something, normally the orthopedic doctor, what he will do? He will take the photography of it by using what? X-rays. Why is he using X-rays? Why not any ordinary light? But ordinary light energy is less. They cannot penetrate. But X-rays energies are more and easily they can what? Penetrate through it here. And that. The affect photographic film, that is what? As you know that here, all whatever that is the bone part is there, no, that image is present on the what? On the film also. They affect the photographic film. They have wave-like characters. They explained here. They have wave-like characters. That's why they exhibit the phenomena of what? Reflection, refraction, diffraction, polarization, etc. Okay. Next. X-rays are highly penetrating and invisible radiation. But only this reason is that now it is visible reason. That is what? All this visible reason, you know that 7 colors. So the spectrum, it contains what? 7 colors are there. Next. Let us come to the X-ray production. That is. Here in this X-ray production, the major components of X-ray tube are cathode. This is the cathode, students. This is cathode. This is cathode. Next is anode. This part is what? Anode is. This part is anode. Next one is, it is a glass envelope. What is the glass envelope? Here, this one is. This is the glass envelope. This is glass envelope. It is completely evacuated, that is. Why it is evacuated? There is no air particle at all. There should not be any air particles. There should not be any oxygen, hydrogen, any should not be gas content. Otherwise, what happens now? Ionization phenomenon will be takes place. They may ask a question. Why this glass envelope is completely evacuated? If it is not, then air is present, then particles gets what? The primary ionization, secondary ionization. That I don't want here. That's why it is what? Completely it is evacuated. Evacuated means the pressure is, you cannot make it near 0, but nearly you can make it what? Pressure equal to what? Nearly equal to what? 0 is there. Next, students. Here the cooling arrangement is there. You may ask question, why cooling arrangement is required? I'll tell you later. Because in this phenomena, the lot of heat is liberated, that is. Lot of heat is what? Liberated here. That is. I'll tell you later, that is. In order to remove that heat here, then around this tube, what is required here? The water cooling arrangement is what? It is required. Next. High tension battery. You see, this is the high tension battery. This is the high tension battery. And another battery is there here, students. Here also one battery is there. This battery is used to heat the filament, or else you can call it as filament, nothing but coil. It is nothing but what? Coil. Or cathode. We call it as a what? Cathode also. Here, why you have to heat is, by heating this filament, what happens now? That is, by heating this filament, then thermal energy, that is what? Thermionic emission will be takes place. It is called as a thermionic emission. That is. What is thermionic emission? Where electrons are ejected out. That is, by heating, you see, this is one electron, second electron, third electron. That is what? The electrons are what? Ejected out. How electrons are ejected out? You are heating this, you are passing the current. When you pass the current, by the phenomenon of thermonic emission, the electrons are what? Ejected out. And these electrons are what? Ejected out and all that. Next activity. Next one. Cathode. Cathode. Okay. Now, here the cathode is what? I said that. The source of electrons in the X-ray tube is the cathode, which is the filament of tungsten wire. Because tungsten wire has got high melting point is there. That's why normally they are using the what? The tungsten wire. Why they are using the tungsten wire is because it has got high melting point. That's why we are using the tungsten wire. By heating this filament, the electrons are emitted out. By which emission process? It is called as thermionic emission, and the electrons emitted now, those are called thermions or thermoelectrons. Some books they will call it as thermions or nothing but what? Thermal electrons and all that. Next. Here, the negative terminal of the high tension battery is connected to the cathode. You see, this battery. This. Why it is called cathode is because this terminal, it is connected to what? Negative terminal of this. That's why it is called as a what? Cathode here. Cathode. Okay. Next is anode. The word itself indicates that anode is connected to the battery. That is positive terminal of the battery is connected to this. Here, sometimes this anode is also called as a target material. It is also called as target. The word itself indicates that target means where the electrons are allowed to hit on the target. Electrons are allowed to hit on the target. Next. Anode is made up of high melting point materials like tungsten. Here, anode is also high melting point material. Cathode is also made up of what? High melting point, because you are passing very high current, you are passing, and also heat is also more here. That's why anode is made up of high melting point materials like tungsten, and also it acts as a what? It acts as a what? Target. See, high melting point, and also it acts as a what? Target. Next, glass envelope. I told you that is. It is completely evacuated, students, in which both cathode and anode are enclosed. Around the glass envelope, some cooling arrangement is made to remove the what? Heat generated during the X-ray production. Already explained. Next, electrons are emitted by the cathode and they are accelerated towards the anode. This is taking place by the what? High tension battery. I don't know how much you understood this one here, students. Here, 1 minute. Here, pen. Here, voltage you are applying, no? E into V equal to of M into what? V square, students. Here you see, what is it? Electron charge. E is what? Electron charge. V is what? Voltage. If the voltage is more, then electrons gets the what? More and more energy that is. That is converts into kinetic energy. That is, energy of the electrons depends upon the voltage. If voltage is more, then velocity of the electron is also what? More. If voltage is more, then kinetic energy is also what? It is more here. Here, say, 1 minute. Okay. These electrons are there now. Here, just to think it, there are two terminals. This is positive. This is positive plate. This is positive. This is what? Negative plate. Now, when the electrons are there, now suppose electron is there. This electron, it is get accelerated. These electrons are there. Electrons are there. These electrons are attracted towards the what? Positive plate. With what velocity they are moving? It all depends upon the voltage applied. If the voltage is more, then kinetic energy is also what? More. If the kinetic energy is more, then velocity is also what it is? More here. That's why we are applying what? High kinetic energy voltage we are applying. EV equal to high tension battery. What is the purpose of high tension battery? To accelerate the electrons. That is okay. This is your actual tube. This is the actual tube. Here you see cathode is there. This portion cathode is there, and this portion anode is there. Now electrons are ejected out, and they will hit on the what? Target. These are the electron hits on the target. Here there is small valve is there. No, it is completely evacuated. It is and it is sealed also. Same kind is present even in the thermos flask also. It is present. If it is gone, no, that is what it will never act as a thermos flask, or it never acts as a vacuum chamber. It never works. The rest of the parts will leave it. Here it is all internal element. This is the cathode where electrons are emitted, and these electrons are attracted by the what? That is anode portion. This is the anode. Next. Okay. Now look into the spectrum. This X-ray spectrum, it is got two types of spectrum are there. One is continuous X-ray spectrum, continuous, and or else it is called as Bremsstrahlung radiation or Bremsstrahlung spectrum. Also, they will call it as Bremsstrahlung is the name of the scientist. Here you see this line is the one, right? This line continuous. This one, this one, this one. This is continuous spectrum. That means where the energies vary. Suppose 1 electron volt to what? 10 electron volt means all energies are present. 1, 1.1, 1.2, 1.3, 8.9, 8.95, 8.96. Where energy is continuous but not discrete. This is called as a continuous X-ray spectrum. That means where all possible energies are present. For example, energy is 1 electron volt to 10 electron volt means all energies are present here. And students, one more spectrum is there. That spectrum I will call it as a what? Line spectrum, or sometimes it is called as a characteristic spectrum. Line spectrum or here you see this peak is there. No, this is one peak. This is second peak. This peak represents, that is what? One, the spike, or you can call it as a peak, or some books they will call it as a spike. These lines are called as a what? Characteristic spectrum, or sometimes it is called as a what? Line spectrum. Now let us discuss in detail how the character spectrum is obtained and what is properties, and how the line spectrum is obtained and all that. Okay. First I will discuss it. The continuous spectrum, now, where the electron is there. Where the electron has come here? Electron emitted by the cathode. This electron is accelerated, and it is moving towards the what? Target. I told you in a previous here. All electrons are moving towards the what? Target. Target is nothing but what? Anode. They are moving with what? Some kinetic energy of mv square. If the energy is more, then that electron will travels very close to the nucleus. It travels, and then it gets deflected. You see, the high energetic electrons will be travels very deep into the atom, and some electrons will be travels like this. And some electrons it will travel like this. You see, what is the difference? This path, this electron is away from the nucleus center. This electron is, it is what? This path is very close to this, and this is very close to this. If the energy is more, then your energy is more. What happens? What happens? The X-ray energy is also what? More here. Now you see, this electron has got initial kinetic energy. That is what? Kinetic energy. 1 I will call this. And when it comes out, this has got kinetic energy 2, that is final kinetic energy. Listen carefully now. Whenever the electron travels very close to the nucleus or interior of the atom here, it experiences a Coulomb force. It experiences a Coulomb force. Because of Coulomb force, instead of traveling in this direction, it has taken this path it has taken. It is deflected. The particle is what? Deflected in a different direction. And remember, this energy and here the energy, both are what? Different here. Suppose take a ball, then roll it. When it touches to the bench or any table, then what happens? The energy, its direction is what changes. Again, if it hits on the another wall, again direction is what changes. For every change in direction, after change in direction, the kinetic energy will be different. For example, here the initial kinetic energy is 10 electron volt. Here the final kinetic energy is what? 8 electron volt. But there should be accountability is required where this 2 electron volt has gone here. This difference is that now 10 minus of 8 equal to what? 2 electron volt is appears as a what? Energy of X-rays. I think I don't think you understood this. What is 10? 10 is the incoming electron energy. And what is 8 here? 8 is the what? Outgoing electron. What is the initial according to law of energy? I should explain where it has gone, where it is missing this. The missing energy, 2 electron volt, it appears as a what? It appears as a what? X-rays. Now the electromagnetic radiation will what? Emits out. I hope that you understood this. Here, say, here, some electron travels like this, you see, travels like this, and then deflected like this. What is the difference here? This path, that track 1, you see, it is away from the center of the nucleus. It is outside. But this track 2 is what? Very closer. Here, if it is 10 electron volt, here the loss is what? It is what? You know, the 7 to 1. It is 9 electron volt. That means 10 minus of 9 equal to 1 electron volt is the energy of this. That's why in a continuous spectrum, what happens is X-rays of all are what? All energies are what? Possible and all that. Now, I think the time will go short now in 1 minute. Just the incoming electron has got both energetic and also what? Charged. The electrons comes within the proximity of the positive charge nucleus in the target, it will get deflected. Why it is deflected here? It experiences a what? Coulomb force and all that. Whatever the loss of kinetic energy is there, that will be appears as a what? The X-ray energy. Okay. Now, okay, see, I given this equation. H nu equal to of m1 square minus of into what? This one. 1 minute. Okay. Next, what is this? H nu is the what? Energy of the X-rays. What is this here? Initial kinetic energy. What is this here? Final kinetic energy. Read the sentence here. That is. A direct collision of an electron with a target results in a what? Loss of all the kinetic energy of the electron. There is a collision between the electron and the target. Which is target here? Anode is a target. And it is made up of what? Tungsten material. By this, the low wavelength. Pardon? You know? Hello, tell me. Hello. Yenappa? Hello. X-rays are produced and its probability is very, very low. This continuous spectrum is also called as a Bremsstrahlung radiation. It is called as what? Bremsstrahlung radiation. Bremsstrahlung is the name of the scientist and all that. I hope that they may ask a question. Write a note on a continuous X-ray spectrum. How to write? Here the electrons are there. The electrons are emitted by what? Cathode. And they are what? Accelerated by the what? Applied field. And these electrons are, it will hit on the what? Anode. Or when it travels very close to the nucleus, then what happens? It experiences a what? Coulomb force attraction. And also what? This is important. De-accelerate. That is important. I have not used this word here. Say, highlight. This is important. Don't forget. 1 minute. Highlighter. This is that is on. Now this is point. This point is what? De-accelerate. De-acceleration means the energy is what? Decreases. Energy is what? Decrease. That's why given the example. This initial energy is 10 electron volt. This is what? 8 electron volt. And this difference will be appears as what? X-ray energy. The electron causing significant loss in what? Kinetic energy. And there is a change in the water, the trajectory of the electron will be takes place. I hope that you understood this. And also this equation also what you have to write here. Don't think that all electrons are deflected by the same angle. No. Some electrons deflected by more angle, some electrons deflected by the what? Less angle. If they're deflected by the more angle, then X-ray, the loss of energy is what? More. That I'll come to that point. Okay. Now this spectrum, try to understand this spectrum. Very beautiful spectrum it is. Here I drawn that two diagrams I drawn here. One is for the what? One is for the 1 minute. One is for the 50 kilo electron volt. See, this is the 50 kilo electron volt. That. Now for time being, don't worry about K alpha, L alpha, you don't worry this. Don't worry that is. Just to worry about this line. Okay. Students, you see here, very important. Always the graph explains the more thing that is. It speaks more always. The graphical representation always it speaks a lot. Here the wavelength, you see. This wavelength is less. How much wavelength is that? 0.25. You consider it as a 25 and applied voltage is how much it is? 50 kilo electron. This is the back voltage is applied between the anode and the cathode here. This is the applied voltage between anode and cathode. How much it is? 25. This is the graph. This is the graph here. Students, some microscopic level thinking is required. The clinical level thinking is also what required now. You see, when the 50 kilo electron volt is applied, lambda equal to 25 I consider, not 0.25. What is the applied voltage here? 50 kilovolt. Lambda 1 I will call this. Next time you are applying the voltage is how much it is? 25 you are applying. For that, what is the wavelength here? 0.5. Lambda 2 equal to 0.5. What it means? For this, wavelength is less. Wavelength is less. For this, the wavelength is more. If wavelength is less, the energy is what? More. Yeah. Because we know the equation E equal to H C by what? Lambda, we know that. If lambda is less, yes, if lambda is less, then what happens now? If lambda is less, then energy is what? More here. 1 minute. 1 minute. You see, if lambda is less, the energy is what? More. For this, you see, the lambda is less, but energy of the X-rays is more here. That is E1 is more. And for this, you see, that is compared to this, this wavelength is more. When wavelength is more, then energy is what? Can I call it as what? E1 and E2 I can call it as? For this, it is E1. For this, it is what? E2 that is. Which is greater? E1 is greater than what? E2, that is. Please think it yourself. Why E1 is greater than what? E2, that is. Why? E1 is greater than E2. For E1, you see, the applied voltage is what? 50 kilo electron voltage, 50 kilovolt. But for the E2, what is the voltage here? 25 kilovolt. And just now I explained, one equation I explained here is all depends upon the applied voltage. E into V equal to half mV square. If voltage is more, then kinetic energy of the electrons, accelerated electrons are what? Incoming electrons are, this energy is more, that is. Now electrons will be hit the target. Target means N. With more and more energy it will hit. That's why the X-ray energy is also what? More here. This is E1 and this is what? E2 here. Please remember, students. Why E1 is greater than? I will ask you one conceptual question in this graph. Explain why E1 is greater than E2. What is the answer? For this spectrum, the applied voltage is what? More, and for this spectrum, the applied voltage is what? Less. Where the voltage is applied? I am applying the voltage between anode and cathode. Applying the voltage between anode and cathode here. Okay. You see, this is the voltage applied between anode and cathode. If voltage is more, all electrons will be accelerated more here, students. Already explained. Now, this is about the continuous spectrum. Here the question becomes, you explain the production of the X-rays. How will you answer it? You have to draw the neat diagram, you have to draw here. Next, the X-ray tube is consisting, it is a glass envelope. It is completely what? Evacuated, within which one is cathode and another one is what? Anode or enclosed. Very simple that is. It is just the X-ray, whatever portion I am explaining now, it is all more of what? Theoretical part. Just like a Ramayana or Mahabharata. Once you listen to the story properly, in your own language you can write it here. There is no need of what? The repeated reading is also what? Not at all required, my students. Next. Between the anode and cathode, where high voltage battery is what? Connected. And in order to hit the filament of this cathode, very low voltage battery is what? Connected. Around the glass envelope, the heating cooling arrangement is what? Made here. Because during this mechanism, the lot of heat is what? Generates. Students, one more point I've forgotten here. Whatever the energy is there now in this year, there is a wastage of 98 to 99% of wastage of heat is there. It appears as a heat energy. There is a wastage is more. Hardly what 1 to 2% of energy is converted to X-ray, students. Hardly 2%. Even 2% is also more than this. Whatever the energy of the electrons are there, kinetic energy completely will be converted into what? Heat energy. A lot of heat is leveraged here. Energy. Because this is a target. When an electron hits on the target here, where the kinetic energy is converted into what? Thermal energy in all that. That's why we are using what? High melting point materials we are using. This is about the construction and all. How to write the working? By heating the cathode, the electrons are emitted out. And these electrons are what? Accelerated towards the anode and then finally hits on the target here. After hitting the target, that what happens now? That is, the X-rays are what? Emitted out. You see, these are the X-rays of different energy. This is about the what? The production of continuous spectrum and also what? The construction of the what? X-ray tube and all. Now, one more is there. That is what? Spectrum is what? Line spectrum. This is the line. This line spectrum I will explain in the next class. I will explain it here. This is also very, very interesting, and sometimes it is called as what? Characteristic spectrum. Lastly, only 4 minutes is left here according to my watch. Just to summarize it here. Who invented the X-rays? The X-rays are invented by the scientist around the Jan. That is, the X-rays are invented by the scientist around the Jan. And who was the first recipient of the Nobel Prize here? The first recipient of the Nobel Prize is Ron He was the first recipient of Nobel Prize in the year 1901 here, students. In the year 1901, that's Nobel Prize. Why he called as a X-rays? Because these radiations are, at the time, they are unknown to us. And what are the applications of X-rays? X-ray is one of the main diagnostic tool in the medical industry. That is, normally that is something has happened. No, that is whenever the bone is fractured, then immediately we'll approach the doctor. That is, orthopedician doctor will approach. He will go through the what X-rays and all that. Remember, students, only that something has happened to the right hand or something. Don't take the photography of the same organ, same part. Should not be taken more than 3 times, because nowadays X-rays are what very dangerous rays also. It will kill the what even useful cells also. It will damage the cells also. It will change the structure of the RNA and DNA also. Structure it will change, students. And you see, he invented in the year 1895. After several years, 6 years or something, he received the Nobel Prize. Next one is after X-ray, the CT scanning is there. Where CT scanning is there, where it is based on the as the other one, the resolution of the CT scanner is still it is higher than the what X-rays. Sometimes the doctor it may not be possible to what identify which bone is fractured and all that in the clearly, because resolution is more less. In that case, they will go for the what? CT scan. What is CT scan? Computer tomography. Computer tomography scanning, where it has got highly resolution and all that. Resolution is what? Still it is high and all that. And what are the properties of the X-ray they are asking here? The X-rays are wavelength is what? Ranging from 0.01 to what? Nanometer and all that. Next is frequency range is what? 10 to the power of 16 to 10 to the power of 90. They travel at the speed of what? Light. They have wave-like what? Characteristics. And energy varies from 100 electron to what? 100 kilo electron volt here. Next is they release the what? Heat when it interacts with what? Matter. It will be metal or something. And they produce the what? Chemical change and also what? Biological change also. They affect the what? Photographic field. They have wave-like character. X-rays are highly penetrating and invisible radiations. Suppose conceptual question. Why X-rays are used in crystallography? Why X-rays are used by the orthopedician to take the photography of any bone? You should answer because X-rays energies are what? Very high and easily it can penetrate through it. Okay. With these discussions, now I'm going to end this. Thank you, one and all. Students, suppose if you are not comfortable with this, whatever the modification required from my side, please, for my personal number, please message it. You send me a message, then accordingly I will rectify my method of teaching, because it's very new to you also. That is very new to you. As much as possible, I'm using all these pictures I'm using here so that you can easily understand and all. Thank you, one and all. Have a good day.